Hello guys, good morning, good evening, good afternoon from everywhere you are. I'm so happy to be here with another session with Microsoft Zero to Hero. Today is a great day. Weather is great and we can start a great session with our speaker. Let me share some slide about the today and the community before to jump the main session. Today we have a Håkan here. He wants to talk about the AI. This is the AI series of Microsoft Zero to Hero session. Actually, as you know, we are part of Microsoft Learn community, and the Microsoft Learn is a central hub about the learning content. You can choose, you select your learning content based off the certificate, based off the role, based off the learning path. After that, you can ask your question from a lot of Learn experts. You can join from aka.ms Microsoft Learn community. Actually, this is a Microsoft Zero to Hero February calendar. We have one session, all of previous session uploaded on Microsoft Zero to Hero YouTube channel. And finally is our code of conduct. Be aware of other, be friendly and passionate, be welcoming and respectful, be open to all question and viewpoint, be understanding on different, be kind and considerate to other in the chat, in the question. And that now is the time to add Håkan to the stage. Hello Håkan, how are you?
Hello, how are you? I'm fine, thank you.
Great. Håkan, what is the news from AI service? It's news. Is it great? Yeah, is it new and fresh topic? As you know, in the technology around of the world, all of guys talk about the AI. What about the AI new model?
Yes, I think if we say that 2024 was the year for AI assistance, I think we can say that now in 2025, the year has come for AI agents. So I'm going to touch upon that also in my presentation. What are the differences and why would we want to develop AI agents?
Oh, great. Okay, one question before to jump to the session. And some people worry about that the AI work with the AI, some company, and some people lose the job or other thing. What do you think in the future?
Yeah, I think definitely AI is a game changer, but work life will always evolve. So it was the same thing with the introduction of internet, or if we go back, the introduction of the transistor or the introduction of the steam engine. I think what is important for us is to keep ourselves updated and have our own opinions and our own views about the new technologies. How can we use it? When should we use it? And should we actually use it at all?
Yeah, great. Okay, let me add your presentation on the stage. You can start. Let's go.
Okay, thank you so much. Yes, so my name is Håkan Silfvernagel, and I'm going to talk here about how we can enhance our own AI services using a framework called Semantic Kernel, which is an open source framework from Microsoft. But before we start with that, I will just say a couple of words here about me. So I work as an AI evangelist for Soprasteria, which is a big consulting company here in Norway and in Europe. And I'm also a subject matter on AI. I have a number of Microsoft certification. I have been a Microsoft MVP 5 years in a row. And you can also see here on this slide some more information about me. And at the end of this slide, I will also share some QR code references, both about Semantic Kernel, but also QR code to my LinkedIn profile if you want to follow me. I'm also quite involved in the local user community here in Norway. So I'm a part of both some virtual and some in-person communities. So if we take the in-person, I'm one of the organizers for Oslo AI. We do quarterly in-person meetups related to AI, and I'm also part of the Norwegian.net user group in Oslo. And I'm part of two virtual communities. One is the AI42, which is an online AI school that I was a co-founder of. And I'm also running the Azure User Group Sweden together with another MVP, Jonah Anderson. So we do bi-weekly online meetups with Azure-related topics. But that's enough here about me. So the agenda here for today is, first I'm going to talk a little bit here about AI assistants and AI agents, so that we all are on the common ground. Then I'm going to discuss about this new open source framework called Semantic Kernel. And the majority here of my presentation will actually be spent in Visual Studio. So we're going to go run through some demos, and we're going to see how can we actually prototype using Semantic Kernel, and how can we then build a more fully fledged application using Semantic Kernel. And in the summary, I will give you some links here, both to GitHub with some examples that you can try out yourself, and some other reference examples here from Microsoft Learn. But first of all here, so what is AI assistant and AI agents? So I think most of us have already tried out AI assistants. That's typically a type of chatbot where you're using a prompt. It can be ChatGPT, it can be CoPilot, for example. And what's typical for an AI assistant is that it's a conversational tool. That means that you operate it using a prompt. And based on that prompt, you will get back either recommendation, it can suggest information based on the data that it has access to. And you can also fine-tune this AI assistant so that it can give answers that are more suited to your specific questions. You can build RAG applications, for example, so that you can chat into your own private data. But then AI agents, on the other hand, they are much more autonomous. So they don't require prompts. So basically what you can do here is you can give an AI agent a goal, and then give it a goal and give it some tools. And then based on that goal, it can, by itself, it can figure out what kind of tools should I use in order to reach that goal that has been given to me. So for example, it could be a schedule goal. For example, maybe you have some trucks and some workloads that should be carried out by these trucks, and they have different schedules. And then you want to know what is the most optimal schedule for the truck drivers and these different workloads. So then you could ask an AI agent to create that schedule for you. And then if you then have exposed the information about the truck workloads and the schedule for the truck drivers, then it can figure out by itself what kind of function should I call in order to create an optimal schedule for this type of problem. And it can also help you with decision making and taking their own action. And we're going to have a look at all of this here in a very short while. So one of these frameworks that we can use is called Semantic Kernel. So Semantic Kernel is an open source framework developed by Microsoft. But there are also other frameworks you can use for creating agentic application. Like for example, LangChain is another popular framework which is used mostly in Python. So one of the strengths here with Semantic Kernel is that you can actually use it both in C#, in Python, and in Java. So the Semantic Kernel sits like a middleware between your application and the AI code, between the large language models and the code that you are writing for your users. So it helps you to structure your applications, and you can use, for example, plugins. You can create your own plugins, or you can download plugins that other people have created for you. And you can also use external connections. For example, if you want to look up something on the internet, you can either create or you can just use out of the box a Bing connector, so that you can search on Bing for more late news. So if we have a look here in this table, we can see the different kind of services that are supported in these different languages in C#, Python, and Java when we use Semantic Kernel. So we can see that, for example, for text generation and chat completion and text embeddings, then it doesn't matter so much which version we're using. But if we want to use, for example, text to image or text to audio, then as of now, there's only C# which supports that use case. But we probably in the future, this list will be updated so that both Python and Java will have added functionality. And we're going to also have a look at these different services like the text to image and the chat completion in our demos. So one of the tools that we can use here if we want to do prototyping with Semantic Kernel is called Prompty. So Prompty is an addition into Visual Studio Code that will help you so that you can easily get a playground, which is very similar to the AI Foundry playground. And using that playground, you can adjust your prompt and you can adjust to make sure that you actually get the results that you're looking for. We're going to have a look here how we can install this Prompty as an extension to Visual Studio Code and how we can use Prompty in order for us to prototype an application that I will demonstrate to you quite soon. So with Prompty, as I mentioned here, you can either use it in Visual Studio Code. So in Visual Studio Code, you add it as an extension, and then you will get a new file extension called .prompty. And you will also get some templates so that you don't have to start from scratch. So basically what Prompty gives you is a very nice structure here where you can provide the context for the large language model. You can provide a system prompt and more information so that you can get the type of answers that you would like to have. And then for us to run it, it's actually very easy. You just need to press this play button in order to run the Prompty. And then a prerequisite here is that you need to have installed, you need to have configured a connection here to an LLM, which can either be the Azure OpenAI, or it can be OpenAI, or it can be, for example, Hugging Face. But it also provides us with a more graphical test playground. So this is if you don't want to write code, or if you're not so familiar with Visual Studio Code, you can still try out and prototype here with Prompty using this interface. So this interface is very similar to the AI Foundry interface for the chat playground. So basically you can provide a question, and then you can see what type of answers will I get back. And then you can also adjust the context for Prompty and some other user-defined properties here. And the last one that we can also use is here in Visual Studio in plain code. So basically you have configured up your LLM with the key and the deployment name and the endpoint. In this case, it's for Azure OpenAI. And then you create the semantic kernel. And then if you see a little bit further down here in this code here, you create the function from a Prompty file. So that means that you can prototype using this Prompty either in Visual Studio Code or in the Prompty playground. And once you're finished, you can just take your Prompty file with all the instructions, and you can copy and paste it into your Visual Studio solution. And then you can run it from here using this function caller on line 29, where we create the Prompty variable by calling this create function from Prompty file. So basically it will create a function that will be able to communicate with your large language model here. And we're going to have a look at exactly how that is done here in a short while too. So first, I would like to demonstrate here the application that we are gonna try to build. So then I have to preface it with some context. So so I'm from Sweden, and in Sweden around Christmas time, we have this tradition of giving Christmas gifts, and for the Christmas gifts, we also need to supply a handwritten note with something that we call the Christmas rhyme. This Christmas rhyme should be written in a particular way that rhymes, and then we usually also provide a small illustration of what is inside the Christmas gift. You can call it a teaser. So the idea here is that the person who reads this rhyme will get some kind of idea what is inside the packet, but it will not be revealed exactly what it is. So I was thinking that maybe I could use AI in order to create a nice Christmas rhyme and also an illustration. So what I did was that I was using Prompty, and I wanted to have a Christmas rhyme. So then I used some prompt engineering in order to come up with a nice prompt that could create a Christmas rhyme that rhymed in a specific way. And then the second thing that I wanted to do is also to use Prompty in order to create an illustration for this Christmas present. So the way that that I did it was that I requested my large language models to come back with a prompt, and this prompt would create an image for me, and I could use another service, for example, DALL-E, in order to create the actual image. So we're going to have a look at how that actually works. So let me just switch over here to Visual Studio, and we can run this application. An example, one moment here before it starts up. So this is also, I should say, this is a Blazor application here that we have. So then we can create ID here is that you select a gift that you want to give away. So for example, if I select a tie, then I can create a Christmas rhyme for this tie. So I can see what this Christmas rhyme is here. So here it says, on special days when you dress to impress, this tie will surely add to your finesse. With colors bright and patterns neat, you look so sharp, can't be beat. So I think that's quite a nice Christmas rhyme. It's definitely much better than what I would be able to come up with myself here. And then if we press this other button, Fabricate, we can get an illustration here from DALL-E for this tie. And then I've provided in my prompt, I've provided some instructions so that we will get an illustration which is very Christmassy. So we're instructed that it should have Christmas colors, it should be a lot of red, and it should also show either Santa Claus or it should show some packets that are related to this. So here we can see this this Christmas present, and actually now this is also a quite interesting example here, because now it choose to use my tie in order to wrap up my Christmas presents. And maybe that was not the whole idea, but that's the way it can happen sometimes. So so now when we've seen how the end result looks like, we will go back here and see how did we reach this state here. So let me open up VS Code. And here in VS Code, we have a prompt here. One moment here. So here in this code, what we have done here is that we've installed this extension, which is a prompty extension, so that we can use it directly here from VS Code. So as I said in the beginning, what we will get here out of the box is we'll get the template so that we don't need to start here from scratch. So in this template, we give a name here for our function. We also give a description here that this prompt will use a gift item as an input, and it will create the Christmas rhyme back as an output. And then we need to configure which model are we using. So we have already created from before in the Azure portal and Azure OpenAI resource. So we can provide it with the endpoint to our Azure OpenAI resource, and also the deployment name for the Azure OpenAI. And then we provide it also with some parameters like the maximum number of tokens and the temperature, and also what type of format do we want our response back in. And we would like to have it as a JSON object back. And then what is the input format is a string. And we also give it some context here where we give them, where we're using prompt engineering techniques here in order for the LLM to be able to generate this Christmas rhyme. So we say that you should provide the Christmas rhyme for a particular gift, and the rhymes should be in the following format. And then we give them a number of examples here so that it can learn the structure here of the rhymes. And we provide it with a system prompt that here it says that you're an AI assistant who helps people with rhymes for the Christmas gift. And as the assistant, you will write the rhyme based on the gift item and answer in a personable manner, and even add some personal flair with appropriate emojis. Respond using the JSON format by including the original gift and the rhyme. And run this prompt file here now here. So then we can see here, and you could, if you were fast, you could also see that it was calling ChatGPT 4o mini resource that we have set up here from before. And here we can see here that the gift item was a cozy blanket, and then our Christmas rhyme that we got back here was, or is, on a chilly night, here is a gift so grand, a cozy blanket to wrap you hand in hand. Snuggle up tight, feel the warmth and cheer. Merry Christmas, your comfort is here. So here we can, this is a very good environment to do prototyping, because it takes very little time here. If we want to make a change, we can just make a change inside this text file, and then we can just run it over and over again until we reach the state where we are satisfied with what it looks like. So let's say here that we are satisfied with this prompt. So then now we have our first prompt, which will give us a Christmas rhyme. Then the second prompt that we wanted to have is we wanted to have a prompt so that we can get an image. So then in a similar manner here, we are creating a prompt file for our image, and we call this image prompt, and we give it a description that it's a prompt that uses a gift item as an input and creates an image back as output. And actually should have been maybe a little bit more clear, because what it gives back a prompt as an output, and then we will use that prompt in order to create this image. And we will have a look at exactly how that works also in a short while. So in a similar fashion to before here, we are we're creating here the endpoint, and we're creating the deployment, and we configure up here the number of tokens and the temperature, and also what type of object we would like to have. And then we also give it some context there that you should take a gift as an input and turn that into an image prompt for DALL-E 3. And the image should always be Christmas themed, with a lot of red colors and winter details in it. there should be either Santa Claus, reindeers, or the Santa Claus dwarfs in the image. And we give them also a system prompt here that you are an AI assistant who helps people with illustration for their Christmas gifts. As the assistant, you will write the prompt that DALL-E 3 will use to generate the image. And respond using the JSON format by including the original gift and the image prompt. So we can also try out this, what happens if we run this in VS Code. So then we can see here what kind of image prompt we got back here. So then in this case, the gift was a book. And then we get an image prompt here that has a festive Christmas scene featuring a cozy reading nook with a beautifully wrapped book sitting on a table. The setting is adorned with rich red decorations, twinkling lights, and snowflakes gently falling outside the window. In the background, Santa Claus is cheerfully reading a list, surrounded by playful reindeer and cheerful Santa dwarfs. And the atmosphere is warm and inviting and capturing the spirit of the holiday season. So basically what we could use now is we could just copy this image prompt into DALL-E 3, and then DALL-E 3 will generate this image for you, which is this image for us, which is our image that we will use in our application. So now let's say that we are happy now with both these prompts, both the first prompt, which gave us a Christmas rhyme, and also this second prompt, which will give us basically a way to create this image. Then we can compile these things together into a program. So here, basically what we do here is we're loading up this image prompt, and then we create a function from this first image prompt, and then we are running this image prompt here. So then we invoke the image prompt, and we get back an image prompt from that call. And I should also say here, I was a little bit too fast here. So here we start out with our rhyme, with our Christmas rhyme. So we create a function from this prompty file, the Christmas prompty file. And then after that, we invoke this Christmas rhyme so that we get our rhyme back. And then after that, we create a semantic kernel image, semantic kernel, and then we provide it with some arguments here for our image, and then we create this image, and then we send this image prompt over to DALL-E by using this function here, text to image service. So if we provide it with the prompt, it will provide us with an image back. So we can try and run this function here and see what happens. Yeah, so then we have our first breakpoint here at our Christmas rhyme. So if we just go one step beyond that, then we can see here that the Christmas rhyme is, "To my father so wise and dear, this book will bring you joy and cheer. With every page a new adventure awaits. Dive in and see what fate creates." Now we have our Christmas rhyme, and then the next thing that we would like to have is this image. So if we just continue, then we are making the second call is to create this image prompt. We just step over this. Then we can see here that the image prompt is a heartwarming Christmas scene featuring a beautifully wrapped book resting on a cozy snow-covered table. The background is filled with festive decoration in rich red colors, including a Christmas tree adorned with twinkling lights and ornaments. In the foreground, Santa Claus is joyfully reading the book, surrounded by playful reindeer and cheerful Santa Claus. Snowflakes gently fall outside the window, creating a magical winter atmosphere. So then the idea here is that we will take this image prompt and we will send that to DALL-E, and the DALL-E will give back an image with this thing. So if we just keep continuing here. And then usually it takes a while here before we actually see the result here. But now we got the result. So then what we can do is you can copy this thing over here, and then we can just open up our web browser, and then we can paste it over here. Yeah, and then we can see here that we got our Christmas image back. So then the way for us, if we want to use this in a more complex application, is that we can basically just copy and paste our prompt files into an application. So I'm going to show you how that is done too. So let me switch over here to Visual Studio, and let me turn that. So here in this Visual Studio solution here, it's on purpose made maybe a little bit more complex than needed here, but that's just to show how that this actually works in a more complex scenario here. So here we have one solution here, which is called Santa Workshop Azure AI, and this solution has everything that has to do with calling our Azure OpenAI endpoint, everything that is related to that, and all the codes to our LLMs is provided in this project. So for example, we have our prompt files again here. So these are the same prompt files that we had in Visual Studio Code. The first one was this one, create rhyme.prompt. I was just copying and pasting into our Visual Studio solution. And the other one was this one, create image prompting. So this is the one that creates our image prompt that we then send over to the DALL-E 3 solution. And then we also have another which sort of sets everything up here. So here we are adding some things here for Blazor that is needed, but we are also adding this Azure AI product so that we can run the Azure AI. So let's see here. And then we also have some functions that we can call, create image prompt and create rhyme. And we also have some models here. These are the different types of large language models that we can use in our solution. So for example, we're using this one, the DALL-E 3 model, in order to create our Christmas image. And also one other nice thing that I would like to point out in this is if we run this from Visual Studio, and as we can see here, we have one product here called app host, and we've used aspire.net in order for us to be able to do both tracing and logging, and we can also see how many tokens have we used when we communicate with our large language models. And we don't need to provide so much. We also only need to provide which is the project that we are using here, which is this Santa workshop, and then we get the other things here for free. So let me start this code. Let me start this project, and we can see what we get. So now here we can see we get our endpoint here to our application. So let's just create something in our application so that we get something that we can trace or log here. So we select here to create a book. we get the Christmas rhyme again here, and then we create our Christmas image. And we always have to wait a little bit in order for this image to be created. But now we can see here it was created. So then if we go back here to this portal here, then we can see here that we have some things. So for example, in this log here, we can see the different logs, like what have we called. And we can see, for example, here, you can see my mouse pointer. We have done a call to the Azure OpenAI chat completion service. And the prompt, the number of tokens in the prompt was 400 something. And then the total number of tokens was 457. This is a nice way of keeping track on exactly how many prompts that we actually used. And we can also see how long time does different function calls take. For example, the create image prompt. It took here 1 second, and what it now can be. And we can also look here in the details. Then in the details, we can get the values here from the Azure portal for our endpoint. And that can be very helpful here if we want to do some debugging. And it's a similar here. Here we can also get some structure log, and we can see what kind of functions has been called and where is it stored. Right now it's stored just on my local hard drive, and so on. You can also see here the number of prompt tokens that we have used. So this is a little bit on how we can use Prompty in order to do prototyping, and then how can we use these Prompty files in a more complex application. But I think it's also important here to be able to start a little bit also from scratch. So I also prepared some more introductory demos that we can run through here. So let me see here. A moment. I'm just gonna stop this one. So then I'm gonna go over here to another Visual Studio solution. I have over here, and I will also give you a QR code so that you can have a look at this code on your own here in your own time here. But basically, these examples are taken from the official Semantic Kernel GitHub repo. And the idea here is that it introduces Semantic Kernel in a step-by-step fashion. So we start out with quite some more basic examples. And then after that, we show how can we use Semantic Kernel in order to do this planning I was talking about, and also how can we use Semantic Kernel in order to use both plugins and also to use external connections. I'm just going to take a little bit of water here before we continue. So here, in our first example, basically what we do here is we have imported the Semantic Kernel as a NuGet package, and then we can create a builder here by using this call here, where we add our connection here to our Azure OpenAI endpoint. So we need to provide both the deployment name, the endpoint, and also the API key in order for us to use it. So then we have a Semantic Kernel builder, and we build this kernel, and then after that we are basically just using it as sort of a middleware here between our application, which is this application, and our large language model, which is the Azure OpenAI. So we are saying invoke this prompt, and then we are providing with the prompt what color is the sky. If we run this example here, if I set this as a startup project, let me set it as a startup project, and then we can run this. Then what we've done now is we're using Semantic Kernel as a middleware, and then we ask Semantic Kernel to ask our large language models about what the color is of the sky. And it's not super important what we got back here, but we can see that the color of the sky appears blue and so on, and then some paragraphs here about the color of the sky. So this is a very simple example just to show how can we have this thing set up. How do we make sure that our semantic kernel can communicate with our Azure OpenAI endpoint, and how can we call semantic kernel from our application code. So another thing here that we can use is this thing here. So what we do here is we can show how can we do if we want to have a templated prompt so that we can add some variables here, either from the runtime, or we could hard code some variables or some arguments into our semantic kernel. So here we define some kernel arguments. So we define that we have a topic, which is the C, and then when we invoke a prompt, we're using that argument in order to turn this into a templated prompt. So if we run this again here, then we can see here that now we were basically asking about the color of the sea, and then we get back that the color of the sea can vary widely depending on several factors, and then some paragraphs about that. And then another way that we can use this is that we can also add some, let me uncomment this first. So another way that we can use this is that we can also provide it with some settings here for a large language model. So here we're providing it with the max token, and we provide it with temperature, and we also provide it with this topic argument. So if we run this example, yeah, so now we wanted it to provide a story here about a dog, and we can see that it took to take quite a lot of paragraphs here, but this is a way that we can do in order both to send configuration into our large language models, and also at the same time provide it with some input arguments. So these are all examples here on how can we use semantic kernel as a middleware between our own application and our large language model. So another example is this one. So let me set this as a startup project. One moment here. So I was also mentioning here that one of the strengths here with using semantic kernel is the plugin concept. So the plugin enables us as developer to create our own plugins where we can define functions that our semantic kernel can use. So this means that we don't need to explicitly program our semantic kernel in order to use these plugins. We just need to define these plugins in a particular way, and then semantic kernel can figure out by itself which type of plugins do I have access to, and how will I use it. So here, in a similar fashion to our previous example here, we create a kernel, a semantic kernel, and we add our Azure OpenAI endpoint for chat completion, and then we provide here with a directory path for our plugin. So, and then we are also loading our plugin from this plugins directory, and we provide it with some arguments here. So if we have a look here in our plugin folder here, you can see we have plugin, and then we also have a subfolder called fun plugins. And in this fun plugins, we also have a folder called joke. And in this joke folder, we have two files here. One, I expand this thing here. One is a JSON file, a config JSON file, which is a configuration for our fun plugin. So then we provide it with a description. The description here is that this plugin will generate a funny joke. We also provide it with some settings here for our LLM, like the max tokens, temperature, and so on. And we provide it what are the input variables. The input is a jokes subject, and then we will get back a joke here. So this is the skprompt.txt is a text file where we actually provide it with the prompt that the LLM will run. So we see here, write exactly one joke or humor story about the topic below. And then we provide it also with some restrictions here about the joke. And then we provide it here with the type of input. So the input is what type of joke do we want to have. So if we run this program, we can see here. So now we provided it with the input was here. Time travel to dinosaur age was our input. So our joke will be about that. So here comes the joke here from our semantic kernel. So why did the time traveler bring a ladder to the dinosaur age? Because he heard the T-Rex was a little short on friends and wanted to help him reach new heights in socializing. So I'm not gonna comment on the quality of that joke, but we can just conclude that this is also an example here of how we can create our own plugins here. And in this example, we created the plugins by defining a config file, a config JSON file, and also a text file with the actual prompt that will be run. But another way that we can create these plugins comes in our next example is this one. Yeah, so basically here we are showing how can we use these semantic functions in line here. So here we define a prompt and we define some execution settings. And then after that, we provide here an input, and then we want to summarize this input basically. So let us try out this example. If I run this. So the content above was this number of paragraphs here about a Greek god called Deus or Demo. So here we get one paragraph summarization of that content here. So that is just to show that we can do this also by using inline functions. But in our next example here, which is about some light plugins, we're going to see how can we actually provide code here. So this is an example where we have our plugin directory, and then we provide the plugin here in code. So in our light plugin, we have a light model with ID and the name of the light, and also is it on, is it off, and some other parameters. And then by providing some input here into semantic kernel, we can provide both what is the name of this function, which is called getLights, and what is the description. The description is very important because that provides the semantic kernel with some context so that it can understand when and how can I use this function. So that semantic kernel will understand that by using this function, he will get a list of lights and also their current states. For get state, he will get the state of a particular light, for example. So we're going to have a look at how that works here. One moment here. And we can have also look here how we do. And so again, here we create our kernel builder and we build our kernel. And then after that, we are adding from this time, we are adding from type. So now we created our own lights plugin type. and we provide the name here for that plugin. And then we are adding some instructions here. Please turn on the lamp, and then we will get back the status here from that. So if we run this function, and meanwhile, yeah. Yeah, so then we asked our light plugin to turn on the table lamp. So what is important here, as you could see here from our application code, we didn't need to program anything. We just had, sorry about that. We just had our semantic kernel figure out what functions are available to me and which functions should I call if I get an instruction that I want to turn on the table lamp. And this is a very powerful concept. And we can also see in our next example here how we can use this in a little bit more complex example here. So this is here we're using the same light plugin that we had from before, and then in our program again we are building our kernel here, and then we're adding a lights plugin, and then we're also adding a function planning instruction here so that semantic kernel can plan what it should do. So now we can use from our command line application, we can just instruct our semantic kernel to perform some different actions. Like for let us run this, I think is the easiest way to demonstrate how this could work. So here we can ask it get the status of all lights. So here we get the status of all lights, so we can see the table lamp is off and the porch light is off, and so on. And we can just ask it to change the status of all lights, for example. And we can see here that now it switched the status of these different lamps here. So again here, what is important is that we haven't instructed our semantic kernel anything about what kind of how do you turn on or off the light, how do you change the status, or how do you get the status. So it is able to both do planning, to plan in which order should I do it, and when which function should I call. And that is a little bit important here, because if it was asking about the status before it changed the status, it would give us the wrong answer, but now it could figure out by itself that first I should change the status, and then after that should report back what is the status. So I have just a couple of more examples here to show here. So one thing which can be interesting is how do we do here with if we want to have something stored here in memory. So here's an example. Here's an example here where we are creating a builder, and here we're using a text embedding model, and then we are storing here in just in runtime memory some information here about what is my name, what do I do as a work, and how long have I lived in a particular place. And then after that, we are providing it with some questions here. What is my name? Where do I live? And so on. And then it just prints out the answer to these questions. So let us try and run this. Yeah, so here we can see we first provided it with some information, and we stored it in our runtime memory, and then after that we were asking it some questions, and we can see here that we get both a probability So the probability is the probability that this is the correct answer. So it's 0.83, so that's 83% that my name is Andrea is the right answer. And where do I live? It's also 83% that they live in Seattle, and so on. And this in this runtime memory is also possible to store it by implementing a specific some specific code here, so then in specific interface. So then you can store it. You don't need to store it in runtime memory, but you can store it in your own SQL database or any other type of database. So I can see here that we are coming up on the hour here. So let me go back here to my presentation. One moment there. And yes. So basically, to summarize my presentation here, we've seen how can we use Semantic Kernel in order to do chat completions. How do we write our plugins? We could see that there were two ways, either through JSON and the text file, or we could provide it as code. How do we do function calling? How can we use planning and memory, and also about connectors here. So if you want to test this out yourself, I provided you with two QR codes here for the official GitHub for Semantic Kernel, and also an introduction to Semantic Kernel on Microsoft Learn. So if you're interested in this, I highly encourage you to have a look at these two resources. So, and if you want to follow me and connect here on LinkedIn, you can scan this QR code in order for us to connect. So,
great. Great, thank you. Thank you very much. Actually, we have one question on the chat. Let me share with you. You can see on the screen.
Yeah, so the question is, how can we achieve a functionality like self-evolution for content and system prompts? Since they are predefined over time, will the output feel less creative to users and become boring? Is there a way to maintain creativity while ensuring we don't generate out-of-scope outputs? And so the way that we can handle the creativity is through this parameter called temperature. The closer we have temperature to 1, so the temperature is a parameter between 0 and 1. So the closer we have the temperature to 1, the more non-creative it will get. So if we have low temperature, like for example 0.3, it will generate more creative examples. So depending a little bit here on your scenarios, if you, for example, wants to use large language models in order to generate IDs, you probably would like to have a low temperature. But on the other hand, if you're using your large language models in order to check out what type of laws are applicable in a specific use case, then you would probably want to have a higher temperature so that you get a consistent answer from your large language model.
Yeah, great. It seems there is no more question in the chat. And if guys, you have in the future you have a question, you can connect with Håkan, the LinkedIn. You can ask your question in the future, and we can close the session. Thank you, guys. Have a great day. Bye bye.
Bye.